Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hey guys, welcome to our Kotlin course. Thanks again for signing up. The first topic we're going to be covering is the concept of variables. So we're going to focus on syntax and basic variable usage and how this differs from comparable languages such as Java. Now we're going to subdivide this topic into smaller parts. The first part will be just a basic intro into exactly what a variable is and how to use a variable. And then we'll look at the basic syntax of variables in Kotlin versus languages like Java. Our next sections will focus on some commonly used variable types. We'll focus first on the 8 primitives, then we'll cover some more advanced types such as strings, ranges, and nullable variables. After that, we'll take a look at conversion, so how to convert between our variable types, and what restrictions there are to these conversions, which ones we can and can't perform and why. After that, we'll have a couple sections devoted to operators and operations that we can perform on variables. The first few will be some value-changing operators, such as arithmetic, unary, and assignment operators. Then we can focus on condition testing operators. So these will be used to compare variable values. Finally, we can devote a few sections to some more advanced topics. So we can take a look at topics like typecasting, binary and hexadecimal values, and then some of the operators that accompany them, which are called bitwise operators. As well, if there are any topics that you'd like to see more of, then we can absolutely do more videos to them, videos on those topics, and then upload them to the course. Now keep in mind throughout that our variables section and most of these Kotlin intro sections will be geared towards absolute beginners. So if you're an advanced coder and you've been programming for a while, they may seem a little basic at first. So if that's the case, feel free to watch them at kind of 1.5 or 2 times speed, but definitely don't skip over entire sections as we go quite in depth into these topics, so doubtless you'll be able to pick up at least 1 or 2 good pieces of information. As well, the Kotlin syntax is quite different from Java, so that's definitely worth following along, at least for the coding portions. Now, any of the code we write, as well as any comments that I feel are appropriate and are necessary for our further understanding of the topic, I'll include in a text file at the very end, so if you missed anything, not to worry, it will all be within that text file. Otherwise, let's go ahead and get started with our basic variable intro. What's up guys, welcome to the first part of our variables section, and we're just going to go ahead and get started with a brief overview of the whole concept of variables. So in this section we're going to talk about, first of all, what exactly are variables, second of all, where do we use variables within our code, and third of all, how do we structure and use variables in Kotlin, and how is this different from other languages? So first of all, what exactly are variables? Well, if we wanted to get technical, variables are basically a way to store a certain value within memory. Now the type of value stored, so for example a number or a string or a true and false value, and the amount of memory that certain value takes up, totally depends on the type of variable we use. We don't really need to worry about this so much anymore, as memory constraints aren't so much of an issue. If we wanted a more practical definition, we can just kind of think of a variable as a way to associate a certain value with a certain name. So that means that we can store a value within that name, and then we can access that value later on, and assuming it's not a constant, modify that value as well. So I want us to think about the example of maybe if we're building a video game and we have some kind of a character with a certain number of lives. Well, maybe we'll want to keep track of the number of lives that character has, and if that character does something to lose lives, we'll subtract lives. If the character does something to gain lives, we'll add lives. And so we should probably keep track of the number of lives that character has in some variable called number of lives or something like that. So really, they're just a way to keep track of certain values throughout your code. Now, for the second question, where do we use variables in our code? The short answer is absolutely everywhere. I can't think of a single programming language that writes a single program that doesn't use a variable somewhere. Even within our file, without having written anything, except for these comments of course, There are several variables in this main activity class. The first is our saved instance state. This is a variable of type bundle, okay? It's also a parameter kind of variable. So this means it actually only exists within the scope of this function. The second variable I can see is our activity_main variable. Now this is actually located in an entirely different package, which is in a different folder. We can control what's called the access of certain variables, depending on certain access modifiers and where exactly we create the variable. So variables created within functions, for example, can only be reused within those functions. Whereas if we create variables within a class but outside of a function, we can use them kind of all over the place if we choose to. But we'll get more into that, which is called variable scope, once we start talking about classes. For now, we'll use variables pretty much any time we need to store and/or modify a value. So, how do we structure and use variables in Kotlin, and how is this different from other languages? Well, rather than just sitting here and listening to me ramble, I think it's easier for me to show you guys exactly what I mean by structuring and using variables. So let's go ahead, give ourselves a couple of lines, and we'll start writing some actual code. Now, although every variable has to have some sort of type associated with it, so whether this is one of the 8 primitive types, or one of the other native types, or even a custom type that we create, every variable has to have some kind of a type, and that tells a compiler which kind of values can be stored within it. Unlike a lot of other languages, however, we don't explicitly need to declare the type a lot of times. The compiler usually picks up on it automatically. However, for now, we'll declare the type as much as we can, because I think it's good practice until at least you get the hang of it and are comfortable moving forwards without declaring the type. So that being said, we don't actually precede the variable declaration with a type necessarily. We always start off with either var or val. Now the difference between the two is that var is a variable that can change, so it's mutable, whereas val you can think of as a constant. So once we assign a value to a val type variable, this means the value cannot change. Okay, so it looks a little like this. I'm just going to actually put this in a comment. So we have val/var, depending on which one we want. Then we have some sort of a name. And as for the name, we first of all want to choose a name that is indicative of what the variable is doing. Okay, so for example, coming back to the character that we would create who has a certain amount of lives. Well, we'd want to keep track of that number of lives in a variable called something like number of lives or character lives. We shouldn't store this in a variable called something like I, because anyone who looks at that variable, they won't have a clue what that variable stands for. So this is really for the convenience of anyone who's reading your code. It's hard enough to read your own code sometimes, let alone someone else's code, especially when they don't name their variables appropriately. Also, it's typical to name your variables as nouns, so these are kind of object words, and we'll use camel case. So the first word is uncapitalized, and then every word after that has the first letter capitalized. Okay, so after the name comes the type. Okay, we'll talk more about specific types in the next section. For now, this just, again, determines what kinds of values the particular variable can have. Then we usually have an equals, and then the actual value we want to assign. Now, there's a few different ways we can kind of arrange this, okay? So in our variable declaration, we need a val or var, we need a name, and a type. As for the initialization aspect, all we actually need is the val, var, a name, and a value. We don't necessarily need the type. So let's take a brief look at an example of both. So let's act as if we were going to build this character. First of all, we might want to give our character a name. Now this I'm going to store as a constant because I think once we assign a character a name, we shouldn't be able to change that name. So let's call this character name, okay? And we'll give this a type. This is going to be of type string. Okay, for now, just recognize that string values hold kind of text or message values. Okay, so now we have a val, we have a name, we have a type, and we're going to actually give this a value. You know what, I'm just going to go ahead and put my own name in. Okay, so this is a complete variable declaration and initialization. Oh, moved it up there. Although we're not actually using this variable yet, this is complete. So we have val denoting that this is a constant. So if we try to change this value later on, character name equals, I don't know, something crazy like mammoth, We couldn't do this. We see this red squiggly line denoting an error saying that values cannot be reassigned. Okay, so I'm just going to comment this out. Cannot change val values. All right, so again, constant / variable, name, type, and the actual value it takes on. Now let's take a look at a couple of different ways we can also do a similar thing. So let's say the character has both a number of lives and a number of hit points. So each life has a certain number of hit points. Well, these we definitely want to store in variables, not values, because their value should be able to change. I mean, we do want to be able to decrease or increase hit points, and the same with the number of lives. So let's start off with a number of lives. Let's just call this number of lives. Okay, and let's say we don't necessarily know exactly how many lives we want, but we do know that we want this variable and we want it to be of type int, which is just a way to represent whole numbers. So we can just give this a type and we can leave it at that. Okay, we don't actually have to assign it a value right away. In this case, Kotlin is nice enough to assign a default value for us. So in our case, this would actually default to 0. If we then decided, okay, we know now how many lives we should have, say we want to give our character 3 lives, we could do that. We could say number of lives now equals 3. What we couldn't do is say number of lives equals some name such as mammoth. Okay, that's not allowed because we've told the compiler that the variable called number of lives is an integer type, which means it can only hold whole numbers. Once we declare a variable type, it's very difficult to change that type. So we're just going to assign it the value of 3 or something. I think that's an appropriate number of lives to start off with. Similarly, we can actually declare again the var or val, the name, and a value without explicitly telling the compiler what type we're talking about. So let's say we're talking about hit points now. We'll create another variable. I'm just going to give ourselves a bit more space, make it easier to read. And now this is going to be maybe character hit points. Okay, and there we go, that's better. And now I'm just going to set this equal to 100. Okay, so this character is going to start out with 100 hit points per life. Now note how I'm missing something here, but it's still fine, there's no errors. And what I'm missing is the explicit type declaration. So because I've assigned it a value, the compiler is picking up on this. It's saying this is a whole number. We're going to automatically assign it the type of integer. Just like if I had omitted this, the compiler would say, okay, this is definitely a string type variable, okay? But I do want that there for just to prove the point. So we always need the var or val, we always need a name, and then we can choose to either have this, a type, either have a value, or even better yet, both of them. So we've now covered declaration and initializations. This is done in one step. We are declaring the variable name and its type. Initialization is actually giving it a value. And this is using the assignment operator, by the way. But so far we've only been using what are called primitive values, such as the actual string literal and number values like this. What if we had some kind of variable and we want to set it equal to another variable's current value? So let's say we have another variable called enemy hit points, and we want to set it equal to the same value as our character hit points. We can absolutely do that. Let's just set this equal to character hit points. Okay, and this is valid. Again, we don't need to declare the type, but probably a better idea to do so. So now these two variables have equal values. So enemy hit points is 100 right now because character hit points is currently 100. Now I will say that this doesn't mean that these two are always going to be the same. All this means is that enemy hit points current value is taking on character hit points current value. So now if I were to change character hit points later on, first of all spell it correctly. So character hit points equals, I don't know, 200, maybe we've got a massive boost. Enemy hit points right now would still be 100 because it's taking on character hit points value at this point in time. Okay. So this is a very important point to take note of, and it differs very slightly when we do something like this with regards to classes. But again, not to worry about that. We'll cover that in a little bit here. Well, actually quite a while. We need to cover a few topics before we get to classes. Okay, so that just about covers our intro. Don't worry, I will leave some more comments for you, so exactly what values these variables will take on, and just a couple of other notes in a text file. Otherwise, I think we are ready to move on. So just as a very quick summary, what are variables? For our sakes and purposes, without getting technical, variables are just a way to associate a certain value with a certain name. Okay, in a variable declaration, we need to tell the compiler whether it's going to be a constant or a variable. So VAL or VAR, respectively. We need to give the variable a name, a type, and a value. Okay, so we can give either a type or a value or both. Both is recommended where possible. We can later reassign a variable's value, assuming it's not, of course, a constant, just by calling on the name, equals, and then a new value that it can take on, assuming that the new value is of the same type as the original value. We can also set one variable equal to another variable's current value, but this doesn't mean that they're always going to be the same, and they're not actually pointing to the same space in memory. This just means that their values are currently the same. Alright, so in the next section we're going to cover the 8 primitive types, and we'll see what kind of values they can each take. Hey guys, now we've had our basic intro into variables and understand what variables are and how to use them, we're going to take a look at the 8 primitive types of values that variables can take on. So this is not to say that there are only 8 types of variable values. There are essentially infinite types through use of the 8 primitive types, through strings, null values, and we can even create custom types through the use of classes, enumerations, and interfaces. But these are just 8 native primitive types. Specifically, there are going to be 6 different types of numerical values. There are going to be Booleans, and there are characters as well. So let's jump right in by taking a look at our 6 numerical types. Now, why on earth are there so many different numerical types of values? Why isn't there just one that represents all numbers? Well, the short answer is memory usage. So certain numerical types take up a lot less memory than certain other numerical types, and this was really an issue when memory restrictions were very real. So now it's not so much of a problem because our computers have terabytes of memory. But you can imagine when your computer only had, like 64 kilobytes of memory, you really had to be careful about saving the memory where you could. So our 4 numerical types that represent whole numbers, so 4 whole numbers, are basically, actually let's start with the smallest ones. We'll go bytes, shorts, ints, and longs. Okay, so going from left to right, these take up the least amount of memory and the most amount of memory. However, because of these memory restrictions, that means that bytes can represent the smallest range of values, so specifically negative 2 to the power of 8 up to positive 2 to the power of 7 minus 1. And then longs can represent a massive range of numbers, I think from negative 2 to the power of 64 all the way up to positive 2 to the power of 63 minus 1. Now, we rarely need to represent numbers that large, so we don't often go with longs. However, bytes and shorts are very restrictive in the range of values they can hold, so our choice of whole numbers is typically integers. Actually, the compiler also defaults any whole number to an int as long as it's not too big. So, for the most part, I'm going to be working with ints, and I'll just use ints as a demonstration. We declare bytes, shorts, and longs in pretty much exactly the same way. So, we saw a few examples of integer type variables in the previous section. Places we might use them are going to be anywhere where we will need a whole number, such as hit points or number of lives. So we could just create some value, number of lives, and actually this should be a variable really because we know this is going to be a value that will probably change, and it's going to be of type int, and then we'll just set it equal to 3 again. Okay, so similarly we could change this to a byte, okay, we could change this to a short, or even a long. Okay, the only difference is that if we want to declare a long and don't want to explicitly tell the compiler that this is a long, we have to add the capital L onto the end of it. Otherwise, the compiler thinks that this is an int. Okay, so just going to change that back to an int. And again, any notes that any comments that I make that I don't explicitly take notes on, I'll likely add to the text file at the end for your convenience. So if you didn't quite catch something, don't worry about it. It's likely going to be written in a comment at some point. Okay, so there are 6 numerical types. We've covered 4 of them. Let's look at the other 2. And these are going to be floats and doubles. So 2 decimal numbers. Okay, floats and doubles. All right. Again, there are two different types of decimal numbers for memory reasons. Okay, so again, this is 2 to the negative 32 up to positive 2 to the 31 minus 1, and then doubles are basically double that range. Also, doubles have double the precision, which means that we can be twice as precise, we can represent twice as many decimal places as we can with floats. We'll actually rarely need this precision, but the compiler defaults any decimal number to a double rather than a float. So we actually only really use floats when functions explicitly call for floats. An example of where we might see decimal numbers might be something like a bank account, for example. So bank accounts will need to represent dollars and cents, or whichever currency you're currently using. So we might have something like a bank balance. Let's create a variable. We'll call this bank balance. Okay, we'll set this to be of type double, and let's say we have only $100.25 in our bank. Okay, so that's fine. If we wanted to represent this as a float, we could explicitly add the float type, but for some reason our compiler still isn't happy with this, so we have to add the F onto the end of it. This can be capitalized or lowercase. Okay, however, I do want to change this back to a double. Again, like I said, we use doubles a lot more than we use floats. Right, so that covers our 6 numerical types. Next on our list is the Boolean type variable. Now the Boolean type variable is probably the simplest of them all, as it can only hold one of two values. Okay, so that's either a true or a false value, so either 1 or a 0. And in Kotlin they're not literally represented by 1s and 0s. I know in some languages you can actually convert a Boolean, true or false, to a 1 or a 0, respectively. In Kotlin that's not something we can do. But again, Booleans only true or false values, so Booleans are only true or false. And the nice thing is, this means if it's not true, it's false, and vice versa. So very easy to keep track of. We typically use these in logical testing, and anything where we kind of need a yes or no answer. So for example, is the game over? Is your character dead? I know that's a little morbid. Something a little more lighthearted, maybe is the door open? And so on and so forth. And actually that's the example I'd like to use. I think the dead character's a little too morbid. So is door open? And we'll set this to be of type Boolean, and we'll just set this to be false. Okay, so again, if it's not true, it's false, and if it's not false, it's true. Additionally, we can actually set a Boolean value to, or a Boolean variable's value to a Boolean expression. So this means if some expression evaluates to true, then that particular Boolean's value is true. Let me show you an example. Let's say is greater than, and it's going to be of type Boolean, and we'll set this equal to 5 greater than 2. So this is an expression here. It's going to return true in this case because 5 is definitely greater than 2. And so is greater than takes on the value of true. Okay, so either one of these two works, just as long as the right hand side is some kind of expression or just a straight up true or false literal value. Okay, finally we're going to be talking about characters. So characters are basically 1 digit long, and they exist between the single quotation marks. Okay, so characters are basically a way to represent any Unicode character. So the nice thing is we can actually punch in a Unicode itself, so like a numerical code, or we can just specify the character directly. So this can be numbers, these can be letters, these can be symbols, so we can put in like a G, we could put in like a 6 or a comma or something, just as long as its length is exactly 1 and it's between the single quotes. So variable, maybe we'll just go with a character initial. In my case, if you remember from the previous section, my character's name was my own, so I'm just going to say character initial of type character or char, and we're going to set this equal to n. Okay, and by the way, case does matter. A capital N is not the equivalent of a lowercase n. So they have slightly different Unicode characters. We could also enter a Unicode character if we want. I just don't really know many of them off by heart, so I won't be doing that. But we could also, again, represent this with a number. a symbol. Okay, just keep in mind it has to be of length 1, so this is not allowed, nor is, something like this. It has to be of length 1. Another thing to note is if I were to put a number in here, 3, this character 3 is definitely not the same as our number of lives variable, for a few reasons. First of all, ints and characters take up vastly different amounts of space. And second of all, this actually corresponds with a Unicode, with a Unicode, and this is just an integer value. So the actual integer value of this character is vastly different from the number 3, but more on that in the next section when we talk about conversions, or I guess in a couple of sections. Okay, so that covers your 6 primitive types. We talked about the 4 whole number numerical types. We're only really going to be using ints. Occasionally we'll use longs, but I almost never use bytes or shorts. We use them in exactly the same way, however, and we'll talk a little bit more about the differences, and there's a couple subtle weird behaviors that occur when we try and convert between them. We'll get into that in a couple of sections. Then we talked about 2 decimal numbers, floats and doubles. Doubles, again, more commonly used than floats. And we talked about Booleans next, true or false values. We can either give it true or false literal or the value of an expression. And then characters are basically just between the single quotes, 1 digit in length, but other than that can represent anything. I guess I'll just cover the default values and then we can move on to the next section. So the default values for all of our numbers are zeros. So in this case, it's actually 0.0. For the whole numbers, it's just a simple 0. Default Boolean is false. And I think the default character is actually just an empty character. And by the way, the space is also considered a character. Alright, so next up, we're going to be talking about another very, very commonly used type. That's going to be the type strings. We've actually already seen a string example, but it's not quite one of the primitive types. I'll talk about the difference coming right up.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.